Hi, Alex. How you doing today, buddy?
I'm wonderful. How are you there, big guy?
Great, great, great. I have a question for you.
May have an answer for you.
Okay. Let's see. Let's say that you have money is no issue, and you can do research on whatever you want.
What am I going to do research on?
What is your research project here?
Man,
Don't do oak trees. You already done that. You can't do it
yeah,
again.
I know. I mean, I probably try to do some of the fish, these deep sea fish that we've been doing, because as we've said before, we know less about the deep parts of our oceans than we know about the surface of the moon. So if I had all the money to put into that, I mean, we'd find so many new species.
That's true.
We'd be able to study so many specific species much more in depth. I mean, That'd be that'd be incredible. That, or I'd put it into like either some dendrology research, like in like rainforest dendrology, because that's constantly changing. Like there
Right.
are there's things I've seen where like there's a single species of tree in the rainforest will only exist within like a 100-meter elevation difference and like on one mountain. Like that's the
Yeah.
only place, and like so this square mile maybe that you find on this one mountain in the Amazon is the
It
only
has like
place you find.
20 trees, and
And
that's
this,
it.
yeah, that's the whole species, and it could very quickly be gone.
Right. But today, everybody, we were talking about Gonorrhynchiformes, the milkfish.
Yes.
But before we
But
begin,
this is life, the complete story. I'm Alex. That is Tyler. We are your hosts. And as Tyler said, our lesson for today is the Gonorrhynchiformes, also known by a couple names, the milkfish, the shelliers. There's a couple different families within this. But first, we always go for our nature in the news.
correct.
So our nature in the news for this week is an article that was published just a few days ago. It is scientists discover unique microbes in Amazonian peatlands that could influence climate change. So it's pretty good that I mentioned the Amazon.
Look at you on the ball.
I'm all over it today. I didn't even look at this ahead of time. So for this, these researchers, they have identified an unknown family of microbes that and uniquely adapted, to the waterlogged, low oxygen conditions of tropical peatlands in Peru's northwestern Amazonian rainforest. And this research shows that these microbes could have a dual role in the carbon cycle and potential to either moderate or intensify climate change, stabilize carbon for long-term storage, or release it as greenhouse
I
gases.
just got this image of these researchers who are doing this coming back to their boss or whoever, and they're like, "We found this new microbe, and it either helps
Or
or
really
it
hurts.
screws it up way worse."
Yeah. Yeah. So these little tiny organisms, like thousands of times smaller than a grain of sand, could have a pretty significant impact on the Earth's climate. This is research done from researchers from the Arizona State University, along with some colleagues from the National University of the Peruvian Amazon. And with these new microbes, I mean, these peatlands are already massive carbon reservoirs, which has been sequestering carbon for millions of years and millions of tons of it. And these peatlands are found throughout the world. You hear them a lot talked about in areas like Canada with the permafrost, and that being an issue because as some permafrost is melting and it's releasing the carbon that's stored in some of this peat. Uh, the United Kingdom had a lot with the bogs. Uh, You find it in like Ireland as well, in the British Isles. And they're saying that these little microbes, because of how they exist, they're able to either help sequester more of that carbon. I'm sure that it's probably something where in high carbon areas, or if they have a lot of oxygen, they're able to sequester a lot of that carbon. But in low oxygen environments, they probably release more of it. And the Amazonian peatlands are the planet's largest carbon vault, with an estimated 3.1 billion tons of carbon that is stored in these soils, which is says here in the article roughly twice the carbon stored in all of the world's forests. So this is a significant amount of stored carbon that, if allowed to be released, I mean, there's nothing we could do to stop it at this point.
Yeah, this is one of those things where, Alex, we were just talking on Thursday about the global temperature has increased to what, 1.5 degrees
Yeah,
Celsius?
yeah, we've reached the 1.5 degree centigrade marker, which we're getting ever closer to the point of no return, as it's called.
Which is what, 3?
I believe 3 degrees Celsius, and this is a global average increase, is
Right.
what that is. So,
So
which
the
may
more
not
the
seem like a lot, it is when you think of how, especially things like trees and other plants have adapted.
and the more the globe warms and the more the Earth warms, the more these microbes release the carbon they've absorbed over time. So really, we're pushing that needle further, faster,
Yeah.
the closer we get to it.
Yes, and it says that these microbes are part of the ancient Bathyarchaea group. So they're not bacteria. They're their own group, I believe. These are typically considered extremophiles, and they're able to, yeah, it says these microbes consume carbon monoxide and convert it into energy while reducing that carbon toxicity within the environment. And as they die and accumulate within that peat formation, they help sequester more of that carbon. But as that peat is being used, or those living microbes are consuming the dead microbes below them, I believe it is actually releasing that carbon instead of allowing it to be sequestered. So it's something that more research needs done into these microbes to figure out exactly how, like, where they're at, how they're helping or how they could be hurting. But it could be a big, they say here towards the end of the article, it could be a key piece of the puzzle in addressing global climate changes and how even these tiny organisms can have a major impact on the globe as well as their local ecosystems.
Righto. If you have nothing else to add on the article, we'll go ahead and we'll move on into our lesson for today. Talking
Yes,
about
sir.
the Gonorrhynchiformes, milkfish, not milkheads. These guys are popular food fish, and some of the more lesser known species in this group are found in both marine and freshwater. So it's really a widespread group found in lakes, rivers, streams, oceans, you name it, it's there probably. They have small mouths and no teeth, and they have that primitive Weberian apparatus. I talked about this last week in our ecology encyclopedia on what the Weberian apparatus is. Basically, it helps amplify sounds by using the swim bladder, so they have better hearing than some of the more primitive fish. These guys also kind of secrete a substance whenever they are injured to alarm other fish in the area that there's something, whether it be predator, human, whatever.
Some sort of chemical signaling.
Mm-hmm. And these guys are originally from the Cretaceous period. Not much else to really talk about in terms of like as a whole. We'll talk about each family more as we go through them. But that first family is going to be Shanidae, which are the milkfish. We have two subfamilies, although most milkfish are extinct. The entirety of the subfamily Rubicinctinae is now extinct. There's the genus Gordincthus, Nanaxthus, and Rubicincthus. Those are all extinct genus of the milkfish. Living genus, we have the genus Chanos, which has the chanos, which is the milkfish. Widespread species of ray-finned fish found throughout the Indo-Pacific area. They are grouped in this order, Gonorrhynchiformes, and are more closely related to the carps, catfish, and loaches, which are the other members of the group we'll be talking about in the next couple weeks. They are found, like I said, in that Indian Ocean as well as Pacific, from South Africa to Hawaii, and from California to the Galapagos, North Japan, south to Australia.
We have a lot of common names throughout all these different areas.
Yeah, pretty much every different country, every different vernacular for where they're found has their own name for it. I don't want to butcher any of them. Yeah. So we're not going to talk. There are a couple other extinct species of Chanos. The Chanos brevis, compressus, forcipitus, torosus, and zignoi are the other species names. And these guys can grow pretty large, almost 6 feet long. but are often caught at about 40 inches long.
And about 1 meter,
Yeah.
roughly.
They're about 31 pounds, and they can be up to 15 years old most often. You can see they have a kind of an elongated body type, although it's kind of compressed as well. Like it's elongated one direction, but compressed the other direction. So it's more torpedo-like.
Yeah.
They're pretty streamlined as well as symmetrical. They got that lone dorsal fin, small-ish pectoral fins, small like what's the word I'm looking comparatively to the rest of the body. Yeah. And they have a relatively small head. The mouth is small and toothless, as we talked about. All members are toothless. They have an olive green body with silver flanks and dark fins. Would you like to add anything else?
I think one thing that is significant, you can see that on the picture there, that they have a really big forked caudal fin, so that very deep fork of the tail fin. They tend to have very fine bones in between the muscles, which makes them difficult to eat. So it's something that is eaten for human consumption, but a lot of prep has to go into it to remove all those bones. But typically they're omnivorous, more opportunistic feeders. The juveniles feeding primarily on plankton, algae, small invertebrates. The adults eating more of those benthic invertebrates, as well as some other smaller fish. But they tend to be schooling fish that school around coasts and islands, especially those with coral. And the fry live at sea for a few weeks and then tend to migrate towards like mangrove swamps, estuaries, and even some lakes. Then they return to the sea when they are mature. These juveniles really like undisturbed coastal ecosystems that kind of have as we said, those mangrove swamps. They're kind of semi-enclosed, pretty calm, shallow, not a lot of predators, and a lot of aquatic vegetation that they can use to hide and swim through. There is a lot, because they are so widely distributed, there's a lot of genetic variation. None of them are considered like subspecies yet, but there is some distinctions between the different areas that they are found. And it says that all these populations are thought to be interbreeding, which is why they're still considered one species. Their genetic diversity overall is still fairly low. So that's why these aren't all individual species of milkfish. They are all just one milkfish.
Right. That'll move us on into our next family, right? This is the only living species in Shanidae, if I read properly.
Correct. Yes, this is the only living species within a single genus within the family Shanidae. So there's only one in this whole family. There's only one species. There's a handful, as we said. There's a completely extinct subfamily. And then even in the subfamily Chaninae, which the Chanos is a part of, there are 7 extinct genus within this. Most of them dating to the early Cretaceous or later Cretaceous period.
Right. So we'll move on into our next family, which will be Gonorrhynchidae.
Correct, which again is a family with only one surviving genus.
Right, and that genus is going to be Gonorrhynchus. So these Gonorrhynchiformes are the Gonorrhynchidae. These are the beaked salmons. They're the beaked sandfish.
They are not true salmon.
Yeah. They date back to the early Cretaceous in the Albian stage of the Cretaceous. There are 5 species within the Gonorrhynchus. A little bit more on what the actual Gonorrhynchus are. They live on the sandy bottoms, as you can see in the picture, a whole bunch of them along the seabed, near shorelines of temperate and subtropical southern hemisphere and East Asian waters. They all have that angular snout that they use to dig into the sand. They also lack a swim bladder. These guys are the last surviving members of the Gonorrhynchidae. Although they have been, as I said, they believe to be diverged from during the Albian stage of the Cretaceous. And the most widespread species, Gonorrhynchus gonorrhynchus, is found scattered throughout the world, reaching about 24 inches long or 60 centimeters. These guys are nocturnal, which is kind of, I don't want to say obvious, but obvious based off of the big eyes that they have. A lot of nocturnal hunters, especially in marine ecosystems, have rather large eyes to help them see in the dark. So these guys are kind of fished commercially in some areas, most notably Australia and New Zealand, where they have a firm and good flavor.
These fish, they get about 60 centimeters or 2 feet in length. So they get relatively large, but as you can see, they're pretty long and skinny.
Yeah, they're really kind of like larger needlefish almost.
Yeah. Yeah, but as we said, there are 5 species that are still surviving. The image here shows, as we said, that most widespread species, Gonorrhynchus. And then our other 4, are Gonorrhynchus abbreviatus, Gonorrhynchus forsteri, Gonorrhynchus grayi, and Gonorrhynchus moselei.
Right. So then we'll move on into our next family, Neridae. These are shelliers. This is the largest group that we'll cover today. There's 4 genera, which is the most we've covered so far.
31 living species. So a lot more than the rest that we've talked about.
A lot more than 1 and a lot more than 5.
Yes. So this family, the species in this family are more freshwater fish, typically living in fast-flowing streams and highland areas. They tend to be pretty small, no more than 15 centimeters or 6 inches in length. There is a second subfamily called Fractolaminae, which is only a single species.
And we'll cover that next.
And that typically inhabits more stagnant or slower moving waters, and they get larger, about 25 centimeters or 10 inches in length. They all have a very elongated body shape, and they can actually, some of them are sexually dimorphic, with the males having a very rosette coloring, so like a very pinkish red coloring on the gill plates, where that is absent in the females. There are some that is called neotenic, which means they retain their larval features into their adulthood.
And as Alex said, there are 31 living species within these 4 genera. The first genera we're going to cover is Chromeria, which has 2 of these species, Chromeria nilotica, which is the naked shellier, and Chromeria occidentalis. That is one ugly fish.
Yes.
Look goofy, especially in the face.
Yeah, they kind of have a funky looking head. But these fish typically found in the fresh waters of Sudan, Mali, and Guinea, in the Nile and Niger rivers of Africa, reaching up to about 4.5 centimeters in length. So pretty small fish.
2 inches.
Yeah.
Some say 2 inches is big.
Behave yourself.
We'll move on to the next genus. Graciixes?
Yes, I do not have an image for this because this is a monospecific genus.
And these guys are native to the Ivindo and Central Congo basins in Africa. Moving on, we have Nerea, which is going to be the largest genus that we're going to talk about. They're all restricted to Africa, and they kind of are spread throughout the entire continent. We got Nerea angolensis, Nerea answerigi, Nerea auriculata, which is the air-breathing shellier. Someone tells me it's got that pseudo-lung.
I'd be a good guess.
Nerea catangae, Nerea lewinsiensis, Nerea medeli, Nerea maxi, Nerea pausquamata, Nerea poli, which is the western shellier, Nerea ruaha, Nerea ruquensis, Nerea scholandersi, Nerea stapersi, Nerea uluguru, and Nerea wittai. And there is another species known as the southern Nerea, occurring only in the headwaters of a couple tributaries of the Crocodile River in the Inkamati River system of South Africa.
And this genus is named in honor of an Austrian ichthyologist, Rudolf Nerr.
And we'll move on into our last genus for this group, Paranerea, another larger group of another larger genus. These guys are all also restricted to Africa. I'm really kind of intrigued to know what the difference is between the two genera.
Enough. I mean,
Thanks.
they look different.
They do.
They have a much more elongated head,
Face.
much larger pectoral fins, at least in this artist rendition, which is of Paraneria camerensis.
So we got 15 species in this group. Paraneria specki, Paraneria tanzaniae, Paraneria thyssi, Paraneria vilhene. And then we'll move on.
I was just going to say most of these most of them described in the mid 1900s, specifically like the 1960s. Some were described a good bit earlier, and then as the most recent, as of 2022, was Paraneria altogrammis. So that is the most recently described species within this genus.
And we will move on into our last family. This is a monospecific family, Fractolamidae, which is the hinge mouth or the snake mudhead. And so they're only found in West Central Africa. And they have their mouth can extend like a small trunk, which I'm just like, are we talking like trunk of a car or trunk of a tree?
I'm guessing trunk of like an elephant, or like how a tapir, like it kind of extends outwards. You're supposed to be a biologist.
Hey, I am.
Amateur.
Amateur biologist.
Yes. Amateurs at best.
They have just 2 teeth, both in the lower jaw. You can kind of see in the rendition there, that lower jaw with the 2 teeth sticking out of it. The mouth can extend up to 30% of the hinge mouth's head length, and it has highly flexible lips. And the mouth is mainly supported by cartilage and other types of connective tissues, lignins, collagen, stuff like that. And the swim bladder has 2 compartments, allowing it to function as a lung, helping it survive in those oxygen-poor environments.
Very cool. Very cool indeed.
And with that, we'll conclude our lesson for the day.
It's a little bit smaller of a lesson, but as we've seen in a number of these groups, even these ones which are pretty well described, there's only a handful of them remaining. Especially as we talked about with the milkfish, there's only 1 species left of 10 or 15 genera.
Right.
So it's something, as we work our way down through the fossil history, you see a lot of these becoming less diverse as time has gone on.
But I have no fear. The show is not over yet. We still have our regular features. Alex, would you like to start us off with our most wanted for the day?
I can do that. So our most wanted for today is the Eurasian roach. It is a fish, Gymnocephalus cernua. It is native to the freshwaters of Europe and Asia, primarily rivers, lakes, brackish coastal waters, but has become invasive in North America, thought to have been brought in ballast water from ships, and it has established populations in the Great Lakes and some of those surrounding watersheds. The issue with these fish is, again, as we talked about last week, they're very adaptable, very resilient, kind of generalist fish. So they are able to adapt to a lot of those different environmental conditions, and they can consume a lot of food sources, as well as they have a very rapid rate of reproduction, allowing them to grow and colonize new areas pretty quickly. And because of that, they have been able to, as many other invasive species, they can outcompete those native fish pretty quickly. And they consume a lot of those small aquatic organisms like zooplankton, insect larvae, even small fish. And they have very hard spines on that dorsal fin that you can kind of see in the image there. making it difficult for them to be predated upon. So they have very few natural predators. And as I said, that high reproductive rate with the females being capable of spawning multiple times in a season allows for a very quick population growth, which then, of course, leads to native species decline. They've been seen to negatively impact valuable sport fish, such as the yellow perch and the walleye, because they compete for food and habitat, and they prey heavily on the eggs of those native species. And as you said, because they're adaptable, they can inhabit both fresh and brackish water, with having low nutrients, as well as a wide range of depths and temperature. So as they continue to spread throughout these non-native water systems, they just continue to have a worse impact, and they can go pretty much anywhere. At least that's fresh or brackish water, so that and them outcompeting those native sport fish is a real issue. So one article that's linked on here that I'm seeing is by 2050 it could cause more than $500 million in species reduction for those valuable fish like the yellow perch, walleye, and whitefish. So some things that are being done, of course, if you see them, remove them. Do not release any of these fish into lakes and rivers. If you're emptying out a bait bucket, do it at least 30 meters away from any sort of shore or water line so that these can't get into these water systems. Don't use them as bait. As we said, they're not very good bait fish because of those very hard spines on the dorsal fin. And if they are an aquarium fish and you don't want them anymore, return them or donate them somewhere like a local school or some sort of other aquarium. Don't just dump them out. And if you have a boat, always drain out the water of your boat or a bilge, a live well, anything that is on the boat that could help these fish transfer to a new location. And they do kind of look like some like juvenile fish of some of the species that they impact, like a juvenile perch or juvenile walleye. So it's always something you have to watch out for with these fish. The coloration is a little different, and that rear dorsal fin is much shorter, and they don't have, like, the perch has some pretty distinct striping. The walleye does a little bit as well. So learn what your native fish look like, so that way you only remove these invasive species. But that is all I have for these guys today. Tyler, if you want to then take us into our amazing species.
Right, so today's amazing species is kind of on brand for what we've been talking about today. We're talking about the southern Nerea, as we talked about. These guys are found in those headwaters, and like the alligator, where's the alligator river, I said?
Thanks. Give me access so I can put up a picture for all the folks at home.
Yeah,
thank you. There we are.
So these guys are endangered. They are found in those headwaters, in Africa, South Africa, Klau River, below the Quina Dam. There's several subpopulations in like the Oxloop, Ellensprout, lots of other rivers in the area that have incredible names. Another population was established in Witwatersrand, a tributary of the Ellens River, following 300 fish from the Oxloop being translocated to that stream. So if Alex could pull up the map.
Yes, sir. Give me just a moment.
So as you can see, we're in South Africa. The yellow region on your map, you can see that's where we know they are. That's their historic range. And the green areas are regions that we are assuming they're at, whether we've seen them through like first-hand eyewitnesses or like through fishermen like that, or they are a historic range. These guys are endangered. They were critically endangered prior to this most recent assessment. So in 2007, they were critically endangered. Now they are only endangered. And the reason they're endangered in the first place is just because of their area of occupancy. They have a highly restricted natural distribution. So they only occupy about 44 square kilometers. And at most, it's about 237 square kilometers. That's not a lot of space.
It is not.
And they have severely fragmented populations. So there is still a decline. Some of the threats we have are dams for water management uses. Those hydroelectric dams are kind of causing interference because you're not allowing it to use the entire waterway for its habitat. You're kind of restricting it to above the dam. As well as some invasive trout species in the area are kind of out competing it for resources. You know, runoff from agriculture and forestry, those herbicides, pesticides, fertilizers, things like that. Also, some alien riparian plant invaders, the wattle and the poplar, destabilize the stream banks, as well as introduced rainbow trout species and largemouth bass, causing issues. We love them. They're great sport fish, and that's probably why they're in that area to begin with, is they're great sport fish.
More than likely, but since they're not native to that area, it's a problem.
Yeah, but we do have successful introductions. As I talked about, there's introductions in the Weltervrensspruit, that tributary of the Ellis River, has an introduced population, originally 300 fish. Now it could be more. I don't have an exact number for you guys, but that's going to cover my amazing species. You know, it's a little smaller fish, just a small species of these Nereidae that we've been talking about today.
Very cool.
I'll toss it back over to Alex. He has our ecology encyclopedia entry for the day.
Indeed, I do. So this is something that we've talked about a good bit. I want to talk, especially last week, we talked about a lot, that bathypelagic zone and just kind of some of the ocean zones in general. So in the image here, it kind of shows a really good indicator of what these look like. So most of what we talk about is that epipelagic and mesopelagic. Those are your lighted zones. So as we said, that epipelagic, that's where you get most of your sunlight. That's where a lot of your algae, phytoplankton, those all live there. And then down into that mesopelagic zone as well. And then once you get below that, specifically what I wanted to talk about is that bathypelagic zone, also known as the midnight zone. That is where you now no longer have any sunlight reaching, and we're in full darkness. As you can see, that starts about 1,000 meters or 3,300 feet deep, extending to about 4,000 meters. And then below that, we have the abyssopelagic and the hadal zone. And those are your very deep water areas where there's the extreme pressures. It's pretty cold. Typically, the water in this area is about 4 degrees Celsius. That's when water is at its most dense. And it actually becomes less dense as it continues to get colder and then freezes to ice. That's why ice floats.
And there's little to no life once you get past that abyssal zone.
Yeah, that abyssal zone, life is very strange, highly specialized for that, like those super deep areas, very cold, very little nutrients. This is those areas when we talk about like that ocean fall is where that plays a critical role in nutrient delivery, because there's not a lot of nutrients in this area either, other than say if you get near those hydrothermal vents where you see a lot of life because it is warmer in that area. But that bathypelagic zone, you see a lot of movement of fish or just any aquatic species within this zone, either from that zone upwards into the sunlight areas, especially at night when the sun goes down, but it's still warmer. That's more of a kind of a survival thing, since then you lose the light. it's easier for them to move without becoming prey. But that is kind of the upper no light zone where a lot of those deeper sea fish we have been talking about live, because there's still available enough nutrients that they can survive. A lot of them can survive without running into too much struggle. But that, I just wanted to introduce to everybody these ocean zones, so when we talk about them, you kind of understand the depth of what we mean, especially once we get below that lighted zone where there's a significant change, especially that nutrient levels, the sunlight, the water temperature, things like that. But that is about all I have to cover for these. I just wanted to introduce this to everyone so they had a better understanding of these ocean zones as we talk about them. Tyler, do you have anything to add for this?
I do not. The zones we talked about them a bunch because we talked about a lot of marine invertebrates throughout the episodes. Those first early couple episodes that were heavy on the marine invertebrates. We've talked about them through the past dozen episodes of fish, because a lot of marine fish.
Yeah.
And we're going to keep talking about them as we continue through the fish. So it's very important you guys understand what we're talking about. And it kind of helps us because we don't have to talk about it. We don't have to cover each week what zones we're talking about. We can
Exactly.
We're talking about the bathypelagic zone. If you guys don't remember, you can refer back to this one.
Yeah. But just a couple little other characteristics just for water chemistry in general. As we talk about, as I said, the pressure. And in this area, the water pressure ranges from 100 to 400 atmospheres. So if you think you're standing at sea level, that is 1 atmosphere of pressure. So all the air above you is pushing down. I think it's like 14.7 pounds per square inch, I think is what it is.
Yeah, something like that.
So that is 1 atmosphere. And every 10 meters you go down in the water, you increase 1 atmosphere of pressure. So the pressure gets very high once you get to that bathypelagic zone. And as you get deeper, it only gets more intense. But in these areas, because there's a lot of pressure and you're kind of well below a lot of those ocean currents, many of the conditions have remained pretty constant, or at least consistent, researchers think, for thousands of years, just because there's not a ton of, you're below the that thermal, it's called the thermocline, which is like the thermal layer. So you don't get a whole lot of mixing within the water because there's water currents from the heating and cooling of the water are not present because there's no sunlight to heat the water to make it rise. But that is my last little bit on that.
All right. So that's going to do it for today's episode, guys. We talked about Gonorrhynchiformes.
Yeah.
That's the word. As always, make sure you guys follow us on Instagram at Life Complete Story. Weekly clips as well as weekly amazing species. Follow us on TikTok at Life Complete Story. TikTok is still around in America. But we post our clips there as well. Potentially other things if we ever get around to them. We like to create new things as we go along.
Yeah. Kind of some of the stuff we kind of come up with on the fly, and it's worked out so far.
Adapt and evolve.
Exactly.
Make sure you follow us on Facebook at Life the Complete Story, where you will find articles that don't quite make it onto the show, either because we find them immediately following the show, or it doesn't really apply to what we're talking about. Subscribe to our page on YouTube at Life the Complete Story, and make sure you hit the notification bell, like, subscribe, follow, comment, do all that stuff. Get the algorithm working in our favor. And the most important part, follow us on Spotify. We haven't done Spotify. Follow us on Spotify at Life the Complete Story. Weekly episodes come up about 7 o'clock on Sundays. And as Alex said, send us an email. If there's something we missed, something you want to hear, doesn't quite fit into a comment or a response or whatever, send us an email at lifecompletestory@gmail.com. We always love to hear your feedback. It's looking pretty empty in there right now, not going to lie.
Yeah, so
just pop in,
feel
say
free.
Hi.
Yeah, feel free. But with that, I have been Alex, and that has been Tyler. We are your hosts for Life the Complete Story. And as we say at the end of every episode, keep learning, learn something new. You'll never know what you find interesting. But thank you all for joining us this week, and we will see you next time.